In this lesson, you will learn to solve quadratic inequalities using a systematic graphical approach. We will cover how to rearrange and solve quadratic expressions, use graphs to identify solution regions, and express solutions in interval notation. Mastering this topic is essential for the Cambridge IGCSE Additional Mathematics syllabus, as it forms the basis for finding the range of values for which functions are defined, determining the nature of roots in discriminants, and solving optimization problems. By the end of this session, you will be able to confidently identify whether a solution should be a single interval or two disjoint intervals. Let us begin with the general procedure for solving these inequalities. First, rearrange the inequality so that one side is 0. For example, x squared plus bx plus c is greater than 0. Next, find the critical values by solving the corresponding quadratic equation equal to 0. You can use factorization, completing the square, or the quadratic formula. Then, sketch the graph of the function y equals ax squared plus bx plus c. Finally, identify the regions on the x-axis where the curve is above or below the axis, depending on whether you are looking for greater than or less than 0. The shape of the parabola depends on the coefficient a. If a is greater than 0, the parabola opens upwards, forming a U-shape. If a is less than 0, it opens downwards, forming an N-shape. Let's look at two specific examples. To solve any quadratic inequality, we follow a logical four-step process. First, rearrange the inequality so that one side is 0. This allows us to compare the quadratic expression directly against the x-axis. Next, we find the critical values. These are the x-intercepts where the curve crosses the x-axis. You can find these by solving the quadratic equation using factorization, completing the square, or the quadratic formula. Third, sketch the graph. We don't need a perfect plot. We just need to know the shape and where it hits the x-axis. Finally, identify the regions on the x-axis where the curve satisfies the inequality. If we want values greater than 0, we look above the x-axis. If we want values less than 0, we look below it. Let's look at the graphical interpretation of quadratic inequalities. The shape of your quadratic graph or parabola is determined by the coefficient of the x squared term, which we call a. If a is positive, the parabola opens upwards, forming a U-shape. Notice how the curve stays below the x-axis between the roots and goes above the x-axis outside the roots. If a is negative, the parabola opens downwards, forming an N shape. In this case, the behavior is reversed. The curve is above the x-axis between the roots. Identifying the correct orientation is the most important step for avoiding simple errors in your final solution. Let us apply our procedure to solve the inequality. X squared minus 5 times plus 4 is less than 0. First, we find the critical values by setting the expression equal to 0. X squared minus 5 times plus 4 equals 0. Factorizing gives us x minus 1 times x minus 4 equals 0. So our critical values are x equals 1 and x equals 4. Since the coefficient of x squared is 1, which is positive, we sketch a U-shaped parabola crossing the x-axis at 1 and 4. The inequality asks for where the expression is less than 0, meaning we look for the part of the graph below the x-axis. This occurs in the single region between the two roots. We write our final answer as 1 is less than x, which is less than 4. Now, let's look at a case where the solution is split into two parts. Solve the inequality. 2x squared plus 5x minus 3 is greater than or equal to 0. We start by solving the equation 2x squared plus 5x minus 3 equals 0. By factorizing, we find that 2x minus 1 times x plus 3 equals 0. This gives us critical values at x equals 0.5 and x equals negative 3. Because the 2 in front of the x squared is positive, we draw a U-shaped parabola. Mark negative 3 on the left and 0.5 on the right of the x-axis. The inequality symbol is greater than or equal to, so we are looking for the regions where the curve is on or above the x-axis. This happens for values to the left of -3 and to the right of 0.5. Since these are two separate regions, we must write them as two separate inequalities. Our final answer is x is less than or equal to -3, or x is greater than or equal to 0.5. To ensure accuracy in your exams, it is helpful to memorize the standard solution forms for a U-shaped parabola where a is greater than 0. Assume we have two roots, alpha and beta, where alpha is the smaller value. Here are the common inequality forms. For f of x less than 0, we solve between the roots. For greater than 0, we solve outside the roots. For less than or equal to, we use inclusive bounds. And for greater than or equal to, we use inclusive outer regions. Notice a crucial pattern here. When the inequality is less than 0, we are looking for the valley of the U-shape, which is a single connected interval between the roots. When the inequality is greater than 0, we are looking for the arms of the U-shape that go off to infinity in opposite directions, requiring two separate inequalities joined by the word or. Always check if the original question uses strict inequalities or equal to signs, and ensure your final answer matches that notation. Let's solve a typical Cambridge IGCSE Additional Mathematics style question. Find the set of values of k for which the equation x squared plus k plus 3x plus 2k plus 3 equals 0 has distinct real roots. In the context of the quadratic formula, distinct real roots occur when the discriminant, b squared minus 4ac, is strictly greater than 0. Here, our coefficients are a equals 1, b equals k plus 3, and c equals 2k plus 3. Substitute these into the discriminant inequality. Now, expand the brackets carefully. We get k squared plus 6k plus 9 minus 8k minus 12 is greater than 0. Simplifying this gives k squared minus 2k minus 3 is greater than 0. We have arrived at a quadratic inequality in terms of k. Let's follow our procedure. First, find the critical values by solving the equation. Factorizing, we get k minus 3 times k plus 1 equals 0. Our critical values are k equals 3 and k equals -1. Next, we sketch the graph. Since the k-squared term is positive, it is a U-shaped parabola. The inequality is greater than 0, so we look for the regions outside the roots. The final solution set is k is less than -1, or k is greater than 3. Even the best students can lose marks on this topic due to simple slips. Let's look at how to avoid them. The most common mistake is solving x squared is greater than 9 and writing only x is greater than 3. This ignores the negative region. If you sketch the graph, you will see that x less than -3 is also part of the solution. Students often try to write two separate regions as a single string, such as 3 is less than x is less than -1. This is impossible because a number cannot be both greater than 3 and less than -1 at the same time. If the regions are separate, use the word or. If you multiply or divide an inequality by a negative number to make the x squared term positive, you must flip the inequality sign. Failing to do this will lead you to choose the wrong region of the graph. To avoid this, try to always keep the x squared coefficient positive. To secure top marks in your IGCSE exam, keep these 3 professional tips in mind. First, always sketch the parabola. Never try to solve a quadratic inequality purely through algebra or mental arithmetic. Even a tiny 5-second sketch of a U-shape or an N-shape will prevent you from picking the wrong region. Examiners often look for these sketches as evidence of your method. Second, check the inequality symbol. Check the original question. Does it use greater than or equal to? If the question includes the equal sign, your final answer must include it too. Using a strict inequality when an inclusive one is required is a classic way to lose an accuracy mark. Finally, test a value. If you are unsure of your final region, pick a number within your solution range and plug it back into the original quadratic. For example, if your solution is between 1 and 4, try plugging in 2. If the result satisfies the inequality, your region is likely correct. This simple check takes seconds and provides peace of mind. It is time to test your understanding. Please pause the video now and attempt these 3 questions. The easy question requires a simple factorization and a single interval solution. The medium question involves a negative x squared term. Be careful with your graph orientation or your algebraic rearrangement. The hard question connects inequalities to the discriminant and coordinate geometry. Remember that does not intersect means the discriminant is less than 0. Take your time with these and resume when you are ready to check your solutions. Let us go through the steps for the first practice question. Step 1. Find the critical values by factorizing the quadratic. X squared minus 7x plus 10 equals 0. Factors to x minus 2 times x minus 5 equals 0. This gives us x equals 2 and x equals 5. Step 2. Sketch the graph. Since the coefficient of x squared is positive 1, we draw a U-shaped parabola. Step 3. Identify the region. We want the region where the curve is less than 0, which is the valley between the roots. The final answer is 2 is less than x, which is less than 5. Now for the medium question. To make this easier, let's multiply the entire inequality by -1 and flip the sign. Now find the critical values. 2x plus 1 times x minus 3 equals 0. So x equals -0.5 and x equals 3. Step 2. Sketch the U-shaped graph for our rearranged expression. Step 3. Identify the region. We need the values greater than or equal to 0, which are the arms of the U-shape. Our final answer is x is less than or equal to -0.5, or x is greater than or equal to 3. Finally, the hard question. If the lines do not intersect, then setting them equal to each other will result in no real solutions. Rearranging into standard quadratic form gives x squared minus quantity 4 plus p times x plus 4 equals 0. For no intersection, the discriminant must be less than 0. Substituting our values, we get quantity -4 plus p squared minus 4 times 1 times 4 is less than 0. This simplifies to p squared plus 8p is less than 0. Solve for the critical values of p by factorizing to get p equals 0 and p equals -8. Since we want the region less than 0, we look between the roots of this p quadratic. The range of values is negative. 8 is less than p, which is less than 0. To summarize today's lesson on quadratic inequalities, remember these essential points. Always follow the systematic procedure. Rearrange to 0, find critical values, sketch the parabola, and identify the required region. This structure ensures you don't miss any steps. The sign of the x squared coefficient determines if your graph is a U-shape or an N-shape. This orientation is the most critical factor in choosing the correct interval for your solution. Use a single combined inequality for regions between the roots and two separate inequalities joined by the word or for regions outside the roots. Always check if the question requires inclusive or strict inequality symbols. Quadratic inequalities frequently appear in questions involving the discriminant and the intersection of lines and curves. Always look for the keywords distinct roots, real roots, or no roots to know when to apply these techniques.